Good evening, class. We are looking at section 3.5, chapter 3 functions, section 3.5 graphing techniques, transformations, section 3.6 absolute value functions. So we covered the sections 3.1 through 3.4. Functions, function notations, domain and range, rates of change and behavior of graphs, composition of functions, and now we're going to look at transformation of functions and absolute value functions. Here's the objectives. Graph functions using vertical and horizontal shifts. Graph functions using reflection about the x-axis and the y-axis. Determine whether a function is even, odd, or neither from its graph. Graph functions using compression and stretches. Combine transformations. Also, graph and absolute value functions solve an absolute value equation. So here's the synopsis of what we have seen as far as composition of functions. First, the rise over run represents the average rate of change of y with respect to x, and there are different ways of representing them, such as m equals delta y over delta x, f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, f of x minus f of a over x minus a, f of a plus h minus f of a over h, and it's basically finding the slope of a line given 2 points, which is very straightforward given 2 points. Now, these are operational functions, f plus g, f minus g, f times g, f over g of x. The algebra function, it's interesting to find the domain, assuming A represents the domain of A and B represents the domain of B, the domain of all of these functions is the intersection of the two. Intersection B, because both f of x and g of x have to be defined. The last one, f of x over g of x, needless to say, g of x can't be 0. So x is the domain of g of x, and g of x goes to f of x, and that creates f o g of x. So the composite function, f o g of x is f of g of x, g of x is g of f of x. And so as far as the domain is concerned, g of x must be defined. So any x not in the domain of g must be excluded. F of g of x must be defined. So any x for which g of x is not the domain of f must be excluded. I think it's pretty straightforward to see how we find it. To do this section, I want to look at the library of functions one more time quickly. These are elementary functions. You should know the graph. For example, f of x equals b or y equals b is a constant such that the domain is all real numbers, or is only the range is only one point b. The identity function f of x or y equals x is a line through the origin with domain and range being all real numbers. F of x equals x squared, known as the square function, and the graph is known as a parabola, and the domain is all real numbers, the range from 0 to infinity for a basic one. Y or f of x equals x cubed, known as a cube function, domain and range are all real numbers. F of x equals square root of x, so the square root function, domain and range are from 0 to infinity. For a cube function, f of x equals cube root of x, domain and range are all real numbers from negative to positive infinity. When it comes to a reciprocal function, f of x equals 1 over x, we have a vertical asymptote, which is the y-axis, horizontal asymptote, which is the x-axis, and in both cases, in this case, x can't be 0, in this case, y can't be 0. To represent exclusion of those, we say the domain is from negative infinity to 0, union 0 to infinity. The same thing goes for the range. So this is the synopsis of what we should know. And now let's look at the new stuff, everybody. Vertical and horizontal shifts. Okay, translations. We are assuming C is a positive value. By applying certain transformations to the graph of a given function, we can obtain the graph of the related function. Okay, so let's see what happens here. If you look at this, it basically gives you what's happening. So look at the first or the same function y equals f of x. This is the function that we start with. Y equals f of x plus c is just the graph of y equals f of x shifted up by c units. F of x minus c is the graph of the same function shifted down by c. So if you add plus c to the y coordinate, it takes it up by c units, or if you subtract it, say it takes it down by c. Y equals g of x, f of x minus c is just a graph of y equals f of x shifted right by c units. The value of g at x is the same as the value of f at x minus c, c units to the left of x. Therefore, the graph of y equals x minus c is just a graph of y equals f of x shifted c units to the right. Y equals f of x plus c is just a graph of y equals f of x shifted left by c units, so f of x plus c in this case. Now, let's look at this simple function everybody is familiar with, f of x equals x squared. And using that, we want to end up with g of x equals x squared plus 3. So one way to look at it is just look at a bunch of points. So let's pick up those easy points, and we know that the x squared for this function, this is 9, 4, 1, 0, 1, 4, 9, right? So what happens for this one? Same numbers add 3. So if I add 3 here, I get 12. 4 plus 3, 7. 1 plus 3, 4. 0 plus 3 is 3. 1 plus 3, 4. 4 plus 3, 7. 9 plus 3 is 12. And if you just plot those pairs, this is the basic function. And this function is the same one, has been shifted up by how many units? By 3 units. So up by 3 units. So the domain doesn't change, both of them negative to positive infinity. But the range for this one was 0 to infinity. For this one, it starts from 3 to infinity. So this is from 0 to infinity for y equals x squared. For the blue one, now it's shifted up by 3 units, so it does have an effect on the range. Now, we can do the same thing here. We look at this column and this column. And now let's subtract 4 according to this. So this is 9 minus 4, 5, 4 minus 4, 0, 1 5 minus 4, negative 3, 0 minus 4 is negative 4, and we continue this rest, minus 3, 0, 5. And if we plot those pairs, here's how they look like. Here's the function of y equals x squared. This has been shifted down by how many units? By 4 units. So again, the domain doesn't change, or real numbers. The domain here for any of those graphs, the same. The range for here changed and does the same thing here. The range starts from negative 4. Look at the y coordinate. The bottom one is negative 4 and goes up. So it has an effect on range, not the domain. Graph functions using vertical and horizontal shifts use the graph of f of x equals square root of x to obtain the graph of g of x equals square root of x minus 2, h of x equals square root of x plus 4. So let's start with easy numbers. Again, we want to make sure that they work. You know square root of x, so square root of this one is 0, this one is 1, 2, 3, 4, 5, 6. Again, on purpose, we are using easy numbers. Of course, if I said 2, then square root of 2, which is about 1.41. and so on. Okay, so you have to come up with the value using a calculator. Square root of x minus 2, we are going to use the same value for the say we want them to be the same, square root of x and square root of x minus 2 to be the same. So that's why we're going to use these values. In fact, in essence, we are looking at the y coordinate, or y coordinates for part A. So we are looking at the second column here. So how do I get to 0 here? If I choose x to be 2, I get 0. How do I get to 1? If I choose 3, 3 minus 2, square root of that is 1. How do I get to 2? Over here was 4, because square root of 4 is 2. But over here, in order for this to give you this answer, so x minus 2. Okay, I want to make sure we understand that. For this one, for example, we want the value of x minus 2 to be 4. So x is 6. Okay. For 3, okay, we want square root of x minus 2 to be 9. So that must be 2 plus 9, or 11. In short, you see that we are adding 2. So take a look at, so for the same value as square root of x, for square root of x minus 2, what should x be? That's the question we are answering. And notice, if you look at the x coordinates for this one versus this one, all you have to do, just add 2 to this column. Because if you plug in here 2, you get 0. If you plug in here 3, you get 1, and so forth. So add 2. So this becomes 2. This becomes 3. 4 becomes 6. 9 becomes 11. 16 becomes 18. 25 plus 2 is 27. 36 plus 38. 36 plus 2 is 38. So that makes it pretty straightforward that when we say absolute value of x minus 2 and we graph the square root of x, right? Because we are supposed to know this basic graph, right? Y equals square root of x. It's shifted right by 2 units. According to according to this column, we move it to the right by 2 units. So what about the domain and range? I hope you see that the domain changes, because the domain for this one was from 0 to infinity. The domain changes to 2 to infinity, but the range is still covering all the positive side of the y-axis from 0. So the range doesn't change, remains 0 to infinity. Now, to do the same thing for here, let's do the same thing and write, see, we want the same as this one, right? And that's what we did. So let's write this column for square root of x plus 4. So how do I get to 0? The square root of what number would be 0? What should I choose for x? Well, in order to make this 0, I have to subtract 4. So if I subtract 4 here, I get minus 4. In order to get to 1, okay, the same thing. We are looking at this column, and so let me use a color. So this one, what did we do here? Let me just make it actually look better. This column, everybody, we added. Now this column has to go here. So we are going to subtract 4. Take a look. The reason we are subtracting 4, look at the first one. If I subtract 4, I get, in other words, minus 4, right? Minus 4 and 4, I get 0. But if I subtract here, okay, 4, then we get square root of, in other words, for that one, subtract 4, square root of 0, if you subtract 4. So we get 1 minus 4, which makes it negative 3. If I put negative 3 plus 4, I get 1, square root of that is 1. If I subtract 4 from this number, I get 0. 0 plus 4 is 4, square root of 4 is 2. So this column, write the same column minus 4. 0 minus 4, 1 minus 4, 4 minus 4, 9 minus 4, okay? When you put it here, so for the same value as square root of x4, square root of x4, what should x be? Subtract 4 from this column. Just subtract 4. This is 32, everybody. Notice, I want to make sure that we understand why. 32 goes in here, plus 4 becomes 36, the square root of that is 6. 21 goes in here, plus 4 is 25, the square root of that is 5. 12 goes in here, plus 4 is 16, the square root is 4. 5 goes in here, 5 and 4 is 9, the square root is 3. 0 goes in here, square root of 4 is 2. Negative 3 gives you 1, square root of that is 1. Negative 4 gives you 0, the square root is 0. So that is what's happening. Therefore, what does it mean if you're subtracting 4? That means you're moving this function to the left by 4 units. So move it to the left by 4 units. So what is the effect on the domain and range? Again, the range doesn't change. It covers the same as before, the positive side of the y-axis, including the 0. But the domain for this one, remember, was from 0 to infinity, but it goes to the left by negative. So from negative 4 to infinity. So it does have an effect on the domain of the function. It makes no difference when it comes to the range. Combining vertical and horizontal shifts, use the graph of f of x equals x squared to obtain the following graph and state its domain and range. G of x equals x plus 3 quantity squared. This is, okay, so you can get rid of that. All right, so let's do the transformation, and we have y equals x squared. We know how it looks like. So there are two transformations. One of them is the plus 3, which means you want to replace the x with x plus 3, which means you are going to move it to the left by 3 units. Move it to the left. Same thing, move it to the left by 3 units. So just for the sake of argument, this one moves here, and the vertex will be located at this point with coordinates negative 3, 0. So replace the x by x plus 3, horizontal shift left 3 units. Now negative 5. Now you're done with that. You're looking at this one, and we are going to apply the negative 5, bring it down by 5 units. Okay, so we're going to move it 5 units down. In other words, if you look at this vertex, 0, 0 became negative 3, 0. Now this becomes negative 3, negative 5. So this one is shifted down, subtract 5, vertical shift down 5 units. So the vertex of 0, 0 moves to negative 3, 0, moves to negative 3, comma, negative 5. Needless to say, You can look at other points. For example, negative 1, 1, negative 4, 1, okay? Negative 1, 1 becomes negative 4, 1. Negative 4, 1 becomes negative 4, 4, okay? 1, 1 becomes negative 2, 1, and now negative 2, negative 4. So you can look at 3 easy points, these 3 easy points, and notice that. Now, as far as the domain and range is concerned, the domain is the same. So that hasn't changed. The domain remains the same from negative to positive infinity. But the range, now that the vertex is located at -3, -5, you look at the y coordinate of the vertex and it opens up. So from -5 to infinity, of course, -5 is included. Use the graph of f of x equals absolute value of x to obtain the following graph and state its domain and range. G of x equals absolute value of x plus 3 minus 5. So I want to quickly remind you that this is very similar to the previous example. We had plus 3 minus 5, the same thing here. So in a matter of comparison, we have the same type of transformation. So first and foremost, the absolute value of x looks like a V shape with the vertex located at 0, 0. So just for the sake of argument, one thing that makes it really interesting, this is going to give you the new vertex located at -3, -5. So first, we are going to apply the absolute value of x plus 3, which makes it shifted to the left by 3 units. So just for the sake of argument, this one now has been shifted to the left by 3 units. So the x coordinate subtract 3. So this is -3, 0. This is -5, 2. This is -1, 2. Now, we are going to apply the -5, everybody. That means bring it down, move it down by 5 units. Move it down by 5 units. The effect is that this one now has coordinates -3, -5. The most important part is the vertex. Everything else, that's fine to know. For example, here, 2 minus 5 gives you -3, okay? And you remember it was, this has, 2, 2 has changed to -1 comma 2, so it goes down. 2 minus 5 is -3, so -1, -3. So that is extremely important to notice. So we moved it down by 5 units. What is the effect? The domain doesn't change. The domain of this one and this one and this one, they're all real numbers from negative to positive infinity. That does not change, everybody. What changes is the range. Going back here or here, the range, it covers the positive side of the y-axis from 0 to infinity. 0 is included. Same thing here. But over here now, because the bottom is -5, so from -5 to infinity. So the range from -5 to infinity. So it does change the range. Okay. So we should be comfortable with this concept, everybody. Graphing techniques, transformation continued. compression, stretches, reflections. We are assuming C is a number larger than 1. Y equals C times f of x is the graph of y equals f of x stretched by a factor of C in the vertical direction because each y coordinate is multiplied by the same number C. In other words, in short, this is the main function y equals f of x. If we multiply it by C, it gets stretched by a factor of C. C is larger than 1 in a vertical direction. If we divide by C, okay, it compresses by a factor of C. If we put a negative sign in front of f of x, it flips over with respect to x. If we put a negative sign in front of x, it flips over with respect to the y-axis. So let's look at each one. So y equals 1 over c of times f of x is the graph of y equals f of x shrunk by a factor of c in the vertical direction because each y coordinate is divided by the same number c. Y equals f times c of x is the graph of y equals f of x shrunk by a factor of c in the horizontal direction because each x coordinate is divided by the same number c. Y equals f of x over c is the graph of y equals f of x stretched by a factor of c in the horizontal direction because each x coordinate is multiplied by the same number c. These two cases, we will get more out of it when we look at trigonometric functions. So that's where we have a lot of usage for that. Y equals minus f of x is the graph of y equals f of x reflected about the x-axis because the point x comma y is replaced by the point x comma minus 1. Y equals minus f of minus x is the graph of y equals f of x reflected about the y-axis because the point x comma y is replaced by the point minus x comma y. So example 5, the graph of y equals f of x is given. Use it to obtain the graph of y equals 2 times f of x. So in short, remember, f represents the y coordinate. So we are stretching the y coordinate by whatever this factor is, happen to be 2. Therefore, y equals f of x is stretched by a factor of 2 in the vertical direction. So the horizontal thing, nothing happens. So everything remains the same. So when that happens, this one has coordinates, for example, power to 1. So it still has the x coordinate power 2, but this gets multiplied by 2. 1 times 2. So this becomes power to 2. So you bring it up. This one becomes 5 power 2 times comma 2. This one still 3 power 2, but it's negative 1 times 2 or negative 2. And of course, this is pi 0. 0 doesn't change anything because the x coordinates remain the same simply because any number times 0 remains the same. So notice power 2 comma 1 goes to power 2 comma 2. This one, the same thing, 5 power 2 comma 2. And this one times 2. So you are multiplying the y coordinates by 2. Y equals f of 3x. So it shrinks by a factor of 3 in the horizontal direction. It works in a different manner. So again, you're dealing with this and you are shrinking this by a factor of 3. So in essence, if you look at the last one, it's actually interesting. It ends with 3 pi. If you look at 3 pi, you basically divide it by 3, and this whole thing takes place right now from 0 to 3 pi. But according to this, it will take place from 0 to pi. So what does it mean? This divided by 3. Okay, we are dividing the x coordinate by 3. We are keeping the y coordinate. So for example, this one, pi over 2, if I divide by 3 becomes pi over 6, 1 doesn't change. 5 pi over 2 divided by 3 is 5 pi over 6. the y-coordinate remains. 3 pi over 2, if I divide it by 3, I get pi over 2 with the same y-coordinate -1. Okay, and the x-intercepts, 0, 0 doesn't change. This one is pi divided by 3, 0. This is 2 pi divided by 3, 0. This is 3 pi divided by 3, or pi, comma 0. So take a look at first those values, pi over 2 divided by 3, 5 pi over 2 divided by 3, 3 pi over 2 divided by 3, and look at the x-intercepts. Starting with the last one, 3 pi divided by 3 gives you pi. 2 pi divided by 3, let me just, if you look at this one, it's pi over 3. If you look at this one, 2 pi over 3. Look at this one, 3 pi divided by 3 is pi. This one is here. This one is here. This one is here. So I think it's pretty straightforward as to what's happening, everybody. As I mentioned, with trigonometric functions, this thing make more sense. Graph and find the domain and range of the function f of x equals minus x squared. Well, we have seen these two columns before, okay? So I'm going to repeat the same. So if we go with minus x squared, simply put the second column has to be negated. For example, if I put -3 here, squared is a +9, negative in front of it makes a -9. So negate this column. -9, -4, -1, 0, -1, -4, -9. And so if you were to graph it, you know this function, y equals x squared. You're supposed to know the graph of essential elementary functions. And now, if you plot just those pairs, you can see it flips over with respect to the x-axis. So what happens to the domain? The domain doesn't change, it's all real numbers. But what happens to the range? This one, the range is from 0 to infinity, but for this one, is from -infinity to 0. The range is -infinity to 0. Let me fix that. I thought I put that. So it's minus infinity, comma 0. So it's minus infinity, comma 0. Okay, so minus infinity, comma 0. Okay. All right. So that's the range from -infinity to 0. When the right side of the function y equals f of x is multiplied by -1, the graph of the new function y equals minus f of x is the reflection about the x-axis of the graph of the function y equals f of x. So basically, that's what happens, everybody. So the right side, again, we are looking at this function y equals x squared. The right side is being multiplied by -1. It flips over. It's a reflection about the x-axis, or simply put, flip it over with respect to the x-axis. It has the same meaning. Graph and find the domain and range of the function f of x equals square root of minus x. And again, just quickly, I want to remind you, it's one of those essential functions that look like this, everybody. We should know the graph. Okay, looks like this. Again, if we choose some numbers, 0 of course gives you 0, -1 gives you +1, the square root of that is +1. -4 gives you +4, the square root of that is 2. -9 times negative, +9, 3. -16 gives you +16, 4. -25 gives you +25, which is 5. This gives you +36 or 6 here. Okay. So if you, and by the way, it's clear, as far as the domain, this, remember, under the radical, when the index is even, has to be positive. So that's why you choose those numbers. For example, if you pick 1 or 2 or 3 or any positive number, this is not a real number. You can't choose that. So if you plot those carefully, okay, 1, 1 corresponds to -1, 1, 4, 2 corresponds to -4, 2, and so forth. You can clearly, this is the y equals square root of x, and now this is reflection about the y-axis. The domain was from 0 to infinity, but now it's from -infinity to 0. And by the way, 0 is included, everybody, okay? 0 is included. And but the range hasn't changed. The range is still 0 to infinity. Everybody, this is bracket, the 0 is included. So is this one. So the difference is the range is the same. The domain for this one, the original function y equals square root x, x is the positive side from 0 to infinity. But for the blue one, y equals square root minus x is from -infinity to 0. So we say when the graph of a function y equals f of x is known, the graph of the new function y equals minus f of minus x is the reflection about the y-axis of the graph of the function y equals f of x. So as it was mentioned previously, there is a reflection going on, but what type of a reflection? So previously, the reflection took place with respect to the x-axis, in short, and now it's with respect to the y-axis. Previously, the negative sign was in front of the right side, but now the negative sign is in front of x, and that's something you got to be very careful of, everybody. Okay, so we can distinguish between the two. Graph the function f of x equals square root of 1 minus x plus 2. So we're going to look at this transformation, and we start with the basic function y equals square root of x. Just as an example, this is 0, 0, this is 1, 1, this is 4, 2. So there are different ways of approaching it. We can start by moving it to the left by 1 unit. So we're going to replace this by x plus 1. And when we move it to the left, for example, 0, 0 becomes -1, 0, 1, 1 becomes 0, 1, fairly easy. Now, reflected with respect to the y-axis, y equals f of minus x is the graph of y equals f of x reflected about the y-axis, because the point x comma y is replaced by minus x comma y. So that's what we are going to do here. So we're going to say, we're going to change the x to minus x. And by the way, minus x plus 1 is the same as 1 minus x. Okay, everybody? So again, according to this reflection, we're going to replace the x with minus x. And we know minus x plus 1 is 1 minus x. And therefore, reflection about the y-axis. Plus 2, 2 units up. Plus 2. So, for example, 0, 0 changed to negative 1, 0. When you flip it over, becomes 1, 0. It's interesting that 0, 1 remains the same. And now that we are going to shift this up, 1, 0, 1 remains the same, 0 plus 2, 1, 2. 0, 1, 0 remains the same, 1 plus 2 is 3, minus 3, 2 minus 3 remains the same, 2 plus 2 is 4. So those are the transformations that will do the job. I like to look at the same question, slightly different second method. So we start with y equals square root of x. In case you want to take a different approach, it is possible, and it may not be the case for all transformations. Some of them you can, some of them you cannot. So we start with the same basic function y equals square root of x. Reflected with respect to the y-axis. So y equals f of minus x is the graph of y equals f of x reflected about the y-axis because the point x comma y is replaced by the point minus x comma y. So reflect. Then notice this one is the same as this one. Minus the parenthesis x minus 1. So we have minus x. Now we have minus x minus 1. It's important to understand what happens here. This moves to this. That means it moves 1 unit to the right. So this is going to move 1 unit to the right, move 1 unit to the right. And it did look like this. So I want to make sure we understand what's happening. So we have y equals square root of minus x. Then we are going to write it square root of minus x minus 1. As you know, it's the same as minus x plus 1, or it's the same as 1 minus x. So we have the same thing, but this is a different approach. And I think this is easier to understand, but it's absolutely your choice. Finally, we move up by 2 units and we get to the same answer as before. So I like the second method better. As long as you are comfortable with one of them, that's good enough. Graph the function f of x equals 3 over x minus 2 plus 1. And we are going to look at transformation, assuming we know y equals 1 over x. Remember, the function y equals 1 over x, the reciprocal function looks like that. Okay, by the way, normally we use, everybody take a look, we use dashed line to represent asymptotes for rational functions. We discuss this further later. So we are going to go with a couple of transformations. For example, I see 3, so I'm going to write it 3 over x, and that means you multiply this one by 3, right? So what are you doing? You are keeping the x coordinate, but you're multiplying the y coordinate by 3. That's the idea. You stretch it by a factor of 3. So 1, this one 1 times 3. 2, this one 1/2 times 3. Negative 1, this one negative 1 times 3. And you get those 3 pairs. Again, as an example. Now I'm going to replace the x with x minus 2. That means I'm shifting it to the right by 2 units. So the same thing shifts to the right by 2 units. And the effect is that your vertical asymptote, which was in both cases the y-axis, has shifted. And now your vertical asymptote has the equation x equals 2. But the horizontal asymptote remains. Let me actually write the equation. The horizontal asymptote remains as the x-axis, which has the equation y equals 0. Now you are going to move it up by 1. When you move this up by 1, okay, for example, if you look at this one, 3 doesn't change, this one is 4. 4 doesn't change, this one is 3 halves plus 1, which is 5 halves, okay? So 1 minus 3 becomes 1 minus 2. And the effect is that your horizontal asymptote is changing. So we are shifting it up by 1 unit. And the horizontal asymptote, which was y equal to 0, now it's y equals 1. So the horizontal asymptote has changed to y equals 1, y equals 1, and your vertical asymptote of x equals 2 has not changed. So, by the way, the reason I'm writing those, because if you were to write the domain and range, you should consider that. For example, if I want to write the domain, I would write domain. Remember, you want to get rid of the vertical asymptote, which is x equals 2. So minus infinity to 2, union 2 to infinity. If I want to go, let me use a different color. If I want to go for the range, then I get rid of y equals 1. So minus infinity to 1, union 1 to infinity. Okay. So those are pretty straightforward, I hope. Find the equation of a function that is finally graphed after the following transformations are applied to the graph of y equals x squared. So number one, we want to shift it to the right by 3 units. So f of x or y, if you want the new one, is x minus 3 squared. Now reflect this one. Okay, so this is gone. Now we are dealing with this. Reflected about the x-axis. Put a negative in front. Now f of x is minus x minus 3 quantity squared. Shift it down by 2 units, so bring it down by 2 units, add negative 2 or simply subtract 2. The graph of f of x is given. Draw the graph of the following functions: y equals f of x minus 3, y equals f of x plus 1. It could be involved, but the easiest way for something like this is to pick pairs and change them. So, for example, this has coordinates. I pick a couple of pairs such as minus 2, 2, okay, 1, 3. I highly recommend you do others. You do 0, 0, you do this one, 1, 2, 3, 2, okay. So I'm assuming you can pick those easy points. So this one, this one, this one. All you have to pick up those 4 points and find out what happens. So f of x minus 3 obviously means you move it 3 units down. Okay, that's the meaning of it. And it may be difficult to see what happens, But just for the sake of argument, if this is 0, 0, and it goes down by 3 units, we go here, the x coordinate doesn't change, but the y coordinate goes down by 3, becomes 0, minus 3. So if you are looking at this one, you bring it down by 3 units, 2 minus 3, so it becomes minus 2, minus 1. And then this one, if you take it down, becomes 1, 0. Okay. Hey, give me a quick second, everybody. And so we are shifting it 3 units down. But as I mentioned, all you have to do, pick up a few pairs. What about this one? Compared to f of x, this is moving 1 unit to the left. So you're going to move this to the left by 1. So just for the sake of argument, if you look at negative 2, 2, and I want to move it to the left, that means subtract 1 from here, you get negative 3, 2. If you look at 1, 3, I'm going to go this way, so 0, 3. Just as an example. Of course, you can do it with all of them, 0, 0, okay? Just write all of them in case of what other color can I use. So this one is negative 2, 2 that I was mentioning. Okay, obviously this is 0, 0. You don't even have to write that. So f of x plus 1, shift the graph of f 1 unit to the left. How about y equals half of f of x? So what we are doing is the shrinkage, okay? The function y equals f of x is shrinking by a factor of 2, multiplying the y coordinate by 1/2 in essence. The graph of y equals f of x is shrunk by a factor of 2 in the vertical direction, multiplied by 1/2. Meaning, for example, this one class, the x coordinate doesn't change. The y coordinate gets multiplied by this number. It's half of 2, so that becomes 1. If you look at this one, 1 doesn't change. 3, half of that, 3 halves. Okay. 0, 0 doesn't change. 3, 2, 3 remains. This is half of that, 3, 1. And so it looks like this. Shrink a graph of f vertically by a factor of 2. So again, pick those easy pairs. If 1 or 2 does it, so be it. If not, you can pick more and do the job. Y equals minus f of x. You know that is reflection when you put the minus in front of a function with respect to the x-axis. So this flips over with respect to the x-axis. So y equals minus x reflects the graph of f about the x-axis. So what happens is that when you reflect it about the x-axis, the x coordinates remain the same. So this remains the same. Minus 2 remains the same, but this becomes negative. So it becomes minus 2. 0, 0 doesn't change. 1 remains, flips over, so 3 changes to minus 3. 3 remains, 2 changes to minus 2. That's the meaning of this. So as an example, I wrote those 2. So it flips over with respect to the x-axis. Let's go over the absolute value equations, reminding everybody by definition, absolute value of f of x is f of x is f of x greater than or equal to 0, minus f of x is f of x less than 0, because absolute value of x equals a represents distance from 0. And if a is positive, x is plus minus a. Absolute. And by the way, absolute value equality or inequality, you have to isolate it first. If a is positive, then you sandwich it between the negative and positive. And if absolute value of x is larger than a, and a is positive, then x is less than negative a, or x is larger than. It's pretty straightforward. I hope we all remember that, and then we take it from there. Graph of the function y equals absolute value of x is a V shape. A domain is all real numbers minus to positive infinity, and range is 0 to infinity. So again, this is reminding you of something we went over previously, but just with perhaps a little bit more details here. Determine the function obtained from a series of transformation done on y equals absolute value of x. Step 1, shift left by 2 units. So we are going to take this and move it to the left by units, by 2 units. So it becomes absolute value of x plus 2. So it looks like that. One easy point is look at 0, 0 becomes minus 2, 0. Number 2, shift up by 3 units. We are looking at this one, and now we want to move this one up. So we no longer look at the original one, but rather the red one in essence, or purple one, and move it up by 3 units. So 0, 0 move to negative 2, 0. And now it goes up to here, negative 2 plus 3. Here, okay. Reflect about the y-axis. When you reflected about the y-axis, you change anywhere you see x, you change it to minus x. So change this one to minus x. So you reflect the green one with respect to the y. This is the y-axis. It flips over. And this one, which had coordinates negative 2, 3. Now you take it to the coordinates 2, 3. So this one. So the green one, and now the red one. Alternatively, f of x equals absolute value of minus x plus 2 plus 3. If you take the negative and distribute it in this manner, so minus the parentheses x minus 2. So this makes it absolute value of minus 1 times absolute value of x minus 2. As you know, absolute value of minus 1 is the same as 1. So it's x minus 2 plus 3. You can look at it this way, which means what? This means 2 to the right, 3 up. Look at the blue one. Look at the blue one. 2 to the right, 3, 1 gives you the rest one. So this is another way of approaching it. So we recall that the absolute value of is x if x is larger than or equal to 0, minus x is if x is less than 0. Absolute value of a function, if y equals absolute value of f of x, then it's f of x if f of x is greater than or equal to 0, and minus f of x if f of x is less than 0. So how do we graph absolute value of some function? That's what we want to pay attention to, everybody. In short, you graph the function without paying any attention to the absolute value. And this is y equals x squared shifted down by 25 units. So you know the graph of that. Then what do? Here's what's important. Graph The part of the graph of f of x that lies above the x-axis remains the same. So this portion is above the x-axis. The blue portion remains the same. The part that lies below the x-axis is reflected about the x-axis. So this portion will flip over. So take a look, class. The blue one doesn't change, but the yellow one flips over because it's negative. That's how you graph it. And this is the graph of absolute value of x squared minus 25. Let's look at one more example to make some sense out of this. Sketch the graph of the function. This is part B of the question. Y equals absolute value of square root of x minus 1. Okay, let's do that. Well, let's go with the basic function y equals square root of x. We graph that. And it's very straightforward to everybody. Now minus 1. That means shifted down by 1 unit. So first, here's the graph, right? Now shifted down by 1 unit. Shifted down by 1 unit. This is 0, 0. Let's just use different. Okay, so this color. So this is 0, 0 clearly. This is 1, 1, right, everybody? Bring it down by 1 unit. Y equals square root of x minus 1, shifted down by 1. Now, what I want you to pay attention to is this. This portion with the green is, and by the way, 1, 1 has changed. 1, 1 now has coordinates 1, 0, right? Because we went down. The green portion remains the same, is above the x-axis. But this is the portion which is below the x-axis. Let me use the blue one. This one is below. So it has to flip over. It looks something like. So this, for absolute value of square root of x minus 1, it should look something like this. So the blue portion, as I said, flips over.